السلام عليكم ورحمة الله وبركاته. أهلا بكم أبنائي وبناتي طلاب الصف الثاني الثانوي. معكم منصة البث المباشر وزارة التربية والتعليم مستر حسام حسن, teacher of chemistry. Now we start in this session now Vsepr. What the meaning of Vsepr? Vsepr is the capital letters for the theory, valence, shell, electron pairs, repulsion theory. In the last sessions, we discussed about many things about the theories which observe the covalent bonds, octet rules, and many theories like VBT, valence bond theory. Now we start on Vsepr, valence shell, electron pair repulsion theory. This means that any central atom have types: number one, lone pair; type number two, bond pair. Okay, the bond pair and lone pair have repulsion force between them. The repulsion force try to constant by decreasing the repulsion force between these bonds. Now, the shape of molecules differ according to free and bonded electrons pairs. While found in the orbitals of central atom, in the covalent molecule, or distributed or configured in spaces around the central atom of the molecule. In this atom, I mean central atom of the molecule, where the repulsions between them is the minimum, very small, to form the most stable shapes of the molecule. Now we have repulsion force between these bonds, and these bonds try to decrease the repulsion force between them by take a definite shape or district shape. These shapes are produced from the what? From the last things for the shapes of the molecule. I have many symbols, diagrams, like what is meaning by AXNEM. The meaning of AXMEN. I mean by N, this N is a bonded pair, but M is the lone pair. How can you define the lone pair and bonded pair by using the electronic configurations? Before explaining the shape of molecules, we need to know the important rules called AXNEM. A is the central atom. X is a number of bonding pair, and E is a number of lone pair. Now I use Lewis diagrams, dots model by diagram of dots model I explained before. Now we can to define our fixed number of lone pair and number of bonded pair by using this rule. These rules here: X bonded atoms to the central atom. A is a central atom. X is a bonded atom to the central atom. Lone pair of electrons control the value of bonds. Why? Why the bond pair doesn't affect for this angle by the central atoms have lone pair, and lone pair it is the central of controlling of the value of bonds angle. Why? Because the lone pair are freely from the other sides, and the other sides is connected with the central atom. I have two directions or two sides for the lone pair: free shapes or free space, and the other is controlled by by bonded with another atom. The lone pair of electrons control the values of bond angles in the molecules because the lone pair of electrons is bound to the nucleus of central atom from one side and spread to the space from other side. While the bond pairs is bound from both sides, while the bond pairs is bound from the both sides, because we have two sides. First side is a central atom, and the other is the bonded atom. Like in H3, I have N is a central atom. Okay, NH, NH. We have three bonds. Each bonds have lone pair. I'm sorry, have bond pair. Nitrogen have lone pair, but nitrogen here is bond pair. Bond pair we have the other sides, or from the both sides is controlling because the directions and two sides between H and N. But lone pair, I have lone pair and nitrogen. This lone pair is attracted with a nucleus in one side only, and the other side is free. Now it is free and controlling the angle of the molecule. With the nucleus of two bonded atoms, valence shell electrons pair repulsion theory, Vsepr, increase the number of lone pair of electrons in central atoms. I sure for this portion. I have bond electron and lone pair. The bond pair repulsion theory, Vsepr, increased in the number of lone pairs of the electrons in the central atom. Of the molecule leads to increase the repulsion force between them, okay, which cause the decreasing value of angles between covalent bonds of the molecules, and in general the repulsion is between what? Between the bond pairs. Now we have an angle. This angles formed here. I have lone pair, and lone pair is greater than lone pair, bond pair, and lone pair, bond pair is greater than bond pair. I mean the repulsion force, and the value of angle, the value of angles between two things. Lone pair greater than lone pair, bond pairs greater than bond pair. Now we discuss the effects of lone pair and bond pair in the value of angle. I mean is X is a bonded atoms of the central atom, A is a central atom. Now, the transfer of the shapes of the molecules. To know the shapes of molecules, we must define number of lone pairs and number of the bonded pairs. The abbreviations of the molecule AXNEM. We have free M in this bonds is BeF2, BeF2, Be2F. I have fluorine and fluorine. This is a linear shape. Okay, this is example number 1, BeF2. Example number 2, BF3. Example number 3, SO2. Now we must discuss each one to know the difference between them in angle and the shapes of them I found here. Now it is the stereo spectrum, or the stereo structure of this bonds is linear. Why is it linear? Because the angle is 180 between the two bonds. Okay, Why is 180? Because we have two bond pair only. We have two bond pair only. When you make configuration of beryllium 2s2, 2s2. Now we have two electron and s in this side and s in this side, so it is the angle equal 180. Number of the number of lone pair is 0, no lone pair here. Now we have two bonded pair, two total, 0 free. If you summations between 2 and 0 equal to 2, 0 is the lone pair, this is the bonded pair, 2 plus 0 equal to the total number of electrons around this central atom equal to. So the AX2 is the symbol molecular structures for this angle and this molecule. BF3, 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 we have B related with 3F, fluorine, 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 and you see here this planar triangle. This is shape is planar triangle. Why is planar triangle? Why is this planar triangle? Because we have three bonded pairs around the boron central atom. Okay, if you make electronic configuration of boron equal to 1s2, 2s2, 2b1, 1s2, 2s2, 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 2b1. Okay, we have three electrons in the central atoms according to dots models of Lewis diagram. We find here number of lone pair equal to 0, number of bonded pairs equal to 3. Now the results total number of electrons equal to 3. Now we have this number of electrons equal to 3, and the value here is 120. Now we have another example, SO2, sulfur dioxide. Sulfur dioxide. This is boron trifluoride and beryllium difluoride, and this explanation of sulfur dioxide. Sulfur dioxide is formed from in this structure. From this structure. Now we have S, we have bond electrons, and two sides we find here it is lone pair. Why? Because sulfur equal to 3s2, 3b4. If you make electronic configuration for the 6 electron s2, b4, s2 and b4, we have two lone pairs, not one lone pairs, but one of them will distribute it to related with two oxygen. Oxygen here needs two electrons to share with it. Okay, but it is not triangle, but it is angular. This is mean angular, not triangle. Angular in this shape is angular because the shapes in this cycles 120. That's number of free electrons equal to 1, or lone pair equal to 1, and number of results of electrons equal to 2. We know thing, very important thing for the calculation of lone pair and bond pair. You can to know many things about that, like the free or lone pairs or bond expected bonded pair to form a molecule. Now we have another example to know the shapes of many molecules. I have CH4. CH4 is the methane molecules. This is a shape of at. I have free ions, I'm sorry, free, or I have lone pairs, no lone pairs here. Carbon related with four hydrogen, and each carbon have four single electrons. And this carbon 1, 2, 3, 4. Now this is carbon. This is carbon AX4. AX4. Why AX4? Because A is the central atom, X is bonded, and 4 the uh, number of atoms related with A. Free M is O, 0, 4 bonded, total number of electrons equal to 4. So it is a tetrahedron or tetrahedral shape. This shape equal that. And the atom here, the angle equal to 109.9. 109.5, sorry. CH4 shape, CH4 angle, CH4 symbol of the this compounds. Now we have NH3, NH3. Firstly, make electronic configuration of nitrogen. Nitrogen atomic configuration, its atomic number equal to 7. Now you write with me nitrogen, helium 2, N 2, S2, 2b3. I have 3 single electrons distributed in 3 single orbitals, bx, by, and bz. And I have S have 2 electrons, lone pair. So we have lone pair on S and nitrogen. So the shape is 3-based pyramid, like that. This is connected, this ball with the ball with ball. This is formed, this is a base, this is a base. 3 base pyramids at the top of the pyramid. Okay, now we have number of electrons here equal to 1, 2, 3. I'm sorry, it is number of electrons equal to 4. 4 pair. I have 1 lone pair. I have 1 lone pair and 3. 1 lone pair and 3 bonded pair is total equal to 4. Total equal to 4 pairs. Now we have another example like H2O. H2O. H2O, this is number of lone pair. Okay, you make electronic configuration of oxygen. Oxygen atomic number 8, helium 2, 2s2, 2b4. Number of electrons in outermost energy level equal to 6. Okay, now equal to 6 is a 2 and 2 and 4. 2 is the lone pair. 2 and a lone pair. This is H2O. Okay, I have 2 lone pairs. I have 2 lone pairs and AX2A2. I have AX2A2. I have 2 lone pairs and 2 bonded pairs. They are related in the same things in the shapes of the molecules. Shape of the molecules. Now we have the shapes is angular. This is angular shapes. Now we finished. Yeah, we finished the table. I told anything about that, about this tables, about the molecule, about the central atoms. How can you make a distribution or electronic configuration of any atomic number of each? And you expected the lone pairs and the free or bonded pairs. you can to know many things, steps. We use Lewis structures guidelines to draw the Lewis structures of BeF2. Now Be attached with two fluorine. We have Be, BeF, and F. Now, step number one, you must know beryllium fluoride molecules according to Vsepr theory. Step one, use the Lewis structures guidelines to draw the Lewis structures of BF2. Now, I make this shapes. Now, step number two, apply the Vsepr notations EX2. Okay, number of central atoms, A, number of surrounding atoms, bonded pairs. Now BeF2AX2. Number of lone pairs, no lone pairs here, no lone pairs here. Now we can to define the number of electrons related or attached with another atom. We have beryllium fluoride molecules in like these shapes according to Vsepr theory, and we have linear shape. Why it is linear shape? Because for the above a molecule Vesper's notation will be AX2E0. AX2E0. Why 0? There's no lone pairs here. No lone pairs here. Okay, use Vsepr table to find the shape AX2. AX2 has linear shape. Linear shape. So the shape of BFT molecules is linear. Now, Vsepr geometries. Vsepr geometries I have in this electron group number 2. We have number 1 types of electron groups, 2 bonds, AX2. According to Vsepr, AX2. NMF molecular shape is linear, and this example is BF2. Vsepr geometrical shapes. The group number is 2 groups, types of electrons. I have 2 bonds. Now the shape is linear. It is a BF2. This is example for the shapes of many things of, or many examples for the Vsepr geometry shapes. Geometry shapes of BF3. BF3, we find BF3 in these shapes as a triangle. Why? The molecular shape of BF3 is plane triangle. This is a planar. It is a plane triangle or AXA axis 3. Using valence shells, electrons, pairs, repulsions, Vsepr theory. Hence, the molecular geometry of BF3 only has 120 degree between these bonds. Angle in the molecules BF3 looks like this. I understand that from the repulsion spore, this is produced 120. What is the molecular geometry of BF3? According to model dots or the diagram of Lewis model, we have B attached with 3F 2 2 2 makes 3F 3 bonds. What is the shapes of it? The step 1 determine the lowest structure of molecules for BF3. It is shown below for full explanations of this and how the figures out Lewis structures in this shapes. Now we to know to understand the Lewis structures, you review the session which explain Lewis model diagram. Now we have three valence. We have 3 valence. and fluorine, each one equals 7. This is number equal to what? Apply the Vsepr notations to molecule, apply Vsepr notation AXE. A number of central atoms, X number of surrounding atoms, E number of lone pairs on central atom. For this one, we can see that it has one central atoms, three surrounding A, and no lone pair of electrons around the center atoms, making SAX3. Step 3, using the Vsepr tables to determine the geometry of BF3. BF3. Identify the central atom. In NH3, nitrogen N, nitrogen N is a central atom, and count the valence of electrons. Nitrogen has 5 valence electrons, and each hydrogen H atom has 1 valence electron. So the total number of the valence electrons is 5 plus 3 times 1 equal to 8. Now, has the rules 5 plus 3 times 1 equal to 8. Central atoms, central atom, the molecule adopts the trigonal pyramidal shapes to minimize repulsion forces between them. Now we find here no BNH3. We have a lone pair in this location or this position, and this angle is 107 in ammonia gas. In ammonia gas. Now we must know the determinations of electron pairs. Now the nitrogen forms 3 using bonds with hydrogen atoms using 3 pairs of electrons. Additionally, nitrogen has 1 lone pair of electrons, and we can to predict the molecular shapes according to Vsepr theory. The shape of molecular and the molecules is determined by the repulsions between electrons pairs, with 3 bonding pairs and 1 lone pairs on the central atom. Now we have to know the shapes of any molecules by using the dots of Lewis model or diagram dots models of it. Identify the central atoms. H2O, we have H2O waters. I have hydrogen and oxygen. In the central atoms, we have oxygen in the central atoms. Count the valence of electrons. We have the valence electrons equal to 6 electrons, and each hydrogen atoms has 1 valence electrons. So the total number of valence electrons is 6 plus 2 times 1 equal to 8. Now we have the shape is angular. We have 2 lone pairs and 2 bond pairs. Determine the molecular, or determine the electron pairs. Oxygen forms 2 single bonds with hydrogen atoms using 2 pairs of electrons. Additionally, oxygen has 2 lone pairs of the electrons. And you can to predict the molecular shapes according to Vsepr theory. The shape of the molecules is determined by the repulsions between the electrons pairs with 2 bonding pairs and 2 lone pairs on the central atoms. The molecular shapes and this H2O is angular. The molecules adopts to a bent or angular shapes to minimize the repulsion force between the angle. I have H2O shapes like that, 104.5 angle. Okay, this is the geometrical shapes of water. The geometrical shape of water. Methane formations are according to Vsepr. Now identify the central atoms in CH4 carbon C is a central atoms. Count the valence theory and the valence electrons. I have carbon has 4 valence electrons, and each hydrogen H atom has 1 valence electrons. So the total number of valence electrons is 4 plus 4 times 1 equal to 8. Okay. Uh, Determine the electron pairs. Carbon forms 4 single bonds with hydrogen atoms using 4 pairs of electrons. There are no lone pairs on the carbon atoms. Predict the molecular shapes according to Vsepr theory. The shape of the molecules is determined by the repulsions between the electron pairs with 4 bonds. I have in this shapes is no lone pairs. Each electrons have a valence pair, or I call this bond pairs. Between these electron pairs with 4 bonding pairs and no alone pairs on the electron central, the molecule adopts the tetrahedral shape to minimize the repulsion force between them. Between what? Between the angle. Therefore, the shape of the CH4 molecule is tetrahedral shape with 109.5. This is angle approximately. Now I have another example for or another shape for the shapes of this angle. We find here CH4 109.5 okay, and this, okay, CH4 in this shape, CH4 CH. This is angle. Observe the shapes of or geometrical shape of methane gas. Now the ammonia we find here differentiations between them. How can you explain decreasing the values of covalent bonds angles in water than ammonia than methane? We have this angle 109, 107, 109. This is the greatest. Why? Why it is the greatest? We find here the repulsion force here, and the repulsion force here is by using, I have 1 lone pair, I have 2 lone pairs. The 2 lone pair is more repulsion force here, less than the repulsion force here, less than repulsion force. So the angle here, this is angle is 109, and the angle equal to Z 105, and this angle equal to 109.5. This is angle determined by the repulsion force between the free and bonded electron, or a lone pair on and bonded electrons. Now we have this is shapes of ammonia gas, shapes of methane gas, and we have shapes of H2O gas. We have, this is a decreasing value of covalent bonds angle in water, ammonia NH3, and methane CH4. Now can be explained by the consideration or considering the number of lone pairs of the central atoms and their repulsions effects according to Vsepr theory. Methane shapes tetrahedrals bond angle approximately equal to 109.5, bond angle approximately I'm sorry. Explanation: methane has no lone pairs on the central carbon atom. The 4 hydrogen atoms are evenly spaced around the carbon, resulting in tetrahedral shapes with bond angle of 109.5. Ammonia and H3 shapes trigonal pyramids, bond angle approximately 107.3. Explanation: ammonia has one lone pair on the central nitrogen atoms. Lone pairs exert greater repulsions than bonding pairs, causing the bonding pairs to the pushed closer together. This is results in the slightly smaller response angles compares to the methane. According to number of lone pairs control the value of the angle. And we have water H2O shapes bent or angular bond angle 104.5. Explanations: what has two lone pairs on the central oxygen atom. The repulsion from these lone pairs is even greater, pushing the bonding pairs closer together and resulting in smaller bond angle compared to ammonia and methane. Now, we have many things according to another theory, molecular or orbital theory, MOT. This is molecular orbital theories states that the valence bond theory considers the formations of covalent bonds in the molecules as results of overlap of some atomic orbitals and combinations or combined atoms. The rest of atomic orbitals which didn't take part in the formation of bonds remains as they were in the free atoms. Now, in the molecular orbital theory, however, the molecular orbital theory consider the molecule as one unit, one unit, like one atom, one unit or big atom with a multi-nuclei in which all atomic orbitals of combined atoms are mixed or hybridized, forming a molecular shapes or molecular orbitals. As atomic orbitals has the symbol SBD. SBD, I mean it, SBD is as a pure orbital or atomic orbital. But I have molecular orbital. Molecular orbital forming from what? From the mixing two atoms by two orbital. These two orbitals hybridized orbital or pure orbitals. So molecular orbitals have symbol sigma, pi, and delta, and so on. Now we finished my my session today, and I finished this theories, and I hope to understand my sessions today, and thank you for good listening, and we will meet you next session inshallah. Wa assalamu alaikum wa rahmatullahi wa barakatuh.